All right, so Miss Maya is out today, and I didn't have a video for 6.2 from last year, which means I don't know, for some reason, maybe I did it live. So get a new recording just for you, just for my 4 grade 8s. So we are going to be working through 6.2. So you're going to need your notebooks out, and you need to write function notation. So we know what a function is. Notation just means a special way to write it. So you're just going to learn a special mathematical way for writing out functions. So we're going to write them like the learning target says, and then we're going to also evaluate them. And remember, evaluate means solve. Okay, so if you need to pause and write that, go ahead. So function notation. So function notation is a method for writing variables as a function of other variables. The variable y becomes what you call a function of x, or f of x, and x is the input. So really you're just changing your idea of y, and instead of calling y its own thing, you're saying y is a function of f, or f of x, which makes sense because if we look at this, I'll just write it over here so I can. So this same equation, 5x plus 1, that's, you guys are used to that. It's regular slope-intercept form. But really, the answer to the problem, or whatever y is, the value of y, depends on x. So you plug in a number for x, it's going to change your y. So that's what it means for function notation, and that's why you call it f of x, a function that depends on x. So the new way, so function notation, how you would change, let me change this color so you can actually see it. The way you would change what you already know, this simple equation, to using function notation is simply this. You would write f of x, that's the way you say it, f of x equals 5x plus 1. So we're basically saying this function, the outcome of this function depends on what you plug in for x. That's what it means. Sometimes you'll see it, I've seen it like this before too, f of x. But I don't want to confuse you, so we're going to leave it like that for now. You won't have to worry about that till like pre-calculus anyways. So f of x equals 5x plus 1. So that's function notation. If you ever see function notation, it says to change it, rearrange your equation so y is by itself, and then just replace y with f of x. It doesn't always have to be f. You can use whatever letter you want. So you could say the function g of x depends on 5x plus 1. The function m of x depends on what you plug in for x. So your variable can change, just like you can pick any variables for anything. Most common is f of x. Okay, so here's how you would use it. F of x equals negative 12x. So I'm going to write this. Often you see it's like the cursive x, the cursive f too, right, with this curly q. F of x equals negative 12x minus 7. Okay, we know what to do with that. It's basically the same equation as y equals negative 12x minus 7. But then it says to solve or figure out what is f of negative 3. So f of negative 3 is question mark. That's what we don't know. Okay, so here's what this means. This simply means, where is this negative 3? This negative 3 is taking the place of x. So that means everywhere I see an x, I'm plugging in negative 3. So let's do that. Negative 12x. Well, what's x? X is negative 3. So I'm plugging in a negative 3 minus 7. Okay, now you're just solving it. What's negative 12 times negative 3? Remember, order of operations. You have to do your multiplication first. Negative 12 times negative 3 is 36. And then what's 36 minus 7? That is 29. So f of negative 3 is 29. So like I said, this looks all complicated, but really all it's telling you to do is plug in negative 3 for x. When you do that, you just solve it like you already know how to do. Let's try some more. The cost to make 4 bracelets is shown in the table below. Write a function using slope-intercept form. What would be the cost to make 7 bracelets? Okay, I'm just gonna start off with slope intercept form because I understand that. We've done that so many times. Y equals mx plus b. We need to figure out the slope and the y-intercept. Okay, my b is crazy. So the slope is, remember, change in y. Let me make that a little better. I'm gonna come up here. Remember, the slope equals change in y over change in x, right? So first of all, we have to come down to the table and figure out what our y and our x are. So we're talking about cost. So our cost is our y, and the number of bracelets is x. So basically, the number of bracelets we can make, I'm sorry, the amount of money we can make, the cost, right, depends on how many bracelets we make. So change in y over change in x. To find the slope, I can pick any 2 points, remember? So I will pick these 2 points here. And if you don't like them written like that, I could say the points I'm picking are 1, 17, and the second point I'm picking is 2, 32, right? Those are my 2 points. If I make 1 bracelet, I make $17. If I make 2 bracelets, I make $32. So my change in y minus my change of x, remember, is just this. Most of my video is just me figuring out how to write with the mouse, x2 minus x1, right? Okay, so let's do that. My y2 is 32, my y1 is 17. So 32 minus 17 over 2 minus 1, 2 minus 1. Well, that's easy. The bottom is 2, or sorry, the bottom is 1, 2 minus 1 is 1. And what's 32 minus 17? Do we know that one? See, I always have to check because I'm like, it's 18, right? 18. 32 minus 17. No, it's 15. Can't do math while I'm on Zoom. Okay, 15 over 1. So that means my slope is 15. Okay, so I figured out this. This is 15. I'm almost there. Now I just need my b. Okay, so for my y-intercept, I could graph it and see where it crosses the line. Or I can plug in some numbers, right? So if I already know m, here's what I mean. Right now I know this, y equals 15x plus b. I don't know b, but I can solve for b. Let's pick a point. Let's pick this guy again, 117. So what does that mean? That means y is 17. Everything else is still the same, equals 15 times x, but now I'm going to plug in my value, my point. I'm using 1, 17, so I can plug in a 1, and then it's plus b. So now when I solve, I get 17 equals 15 times 1 is 15 plus b. That means b has to be 2. I could show the subtraction, but I can look at this and go 15 plus some number equals 17. That means it has to be 2. So my equation in y-intercept, or sorry, in slope-intercept form is y equals 15x, that's my slope, and then my y-intercept is 2 plus 2. There's my linear equation. But the added new thing today is to put it in function notation. So guess what? Here's my function notation. F of, let me write it where I have more space. I'm write it down here. Just gonna put it over here because I can already see myself. I'm gonna squish it. F of x equals 15x plus 2. That's it. That's my answer. All I did was write the equation in slope-intercept form like we know how to do. And then at the end, I just changed the y to f of x. It's a function based on whatever value I plug in from x. Basically, the cost to make the bracelets depends on how many bracelets I'm going to make. So then it says, what would the cost be to make 7 bracelets? Well, that's basically what is the cost if x is 7. So they're asking you to evaluate f of 7. So f of 7 is just going to be plugging 7 in for x. What is 15 times 7 plus 2? I don't know 15 times 7 off the top of my head. So I'm just going to do it on my phone. 105 and 105 plus 2 is 107. So F of 7 is $107. Oh, great. Let's go on to another example. We're going to just do one more. Okay. So this is Rashika records the outside temperature at 6 a.m. It's -3 degrees Fahrenheit. The temperature increases by 2 degrees every hour for the next 6 hours. What will the temperature be at 12 p.m.? Write the function to model the situation, sketch the graph, and then evaluate the function f of 6 or f of 12. Okay, so here's what I'm looking at. I see that she goes outside at 6 a.m. and it's -3 degrees. And then every hour, it increases by 2 degrees. What will the temperature be at 12 p.m.? So we have two kind of ways to think about this, right? One thing is our X is our time. So we could make 6 a.m. be 6, right? And then we know it's 6 a.m. And what's the temperature at 6 a.m.? It's -3 degrees. The other way I could think about it, which I think is more clear, is if we make this actually 0, because we're going to make this our starting time. That's our first point, basically at the 0 hour, right? So the first second she goes out in the morning at 6 a.m., it's -3 degrees. And then every hour after that, we can just say, okay, X is 1 at 7 a.m., X is 2 at 8 a.m. So if this is my start time, that's also helpful because it gives me my y-intercept, right? So I already know that this is my y-intercept. You could do it the other way. There's many different ways you can choose to take the problem and interpret it. I just think this is the easiest. So it's -3 degrees, and the temperature increases by 2 degrees every hour for the next 6 hours. So if it increases by 2, guess what that means? That means my slope is +2. So I can write my equation as y equals 2x, and then my y-intercept is -3, so I can just write -3. Function notation means f of x equals 2x minus 3. Okay, so I have the function. Now let's sketch the graph. So if I'm thinking about how we would sketch this, got that. My y-intercept is -3, 1, 2, 3. That's not the most evenly spaced. You would do a better job with than me. And then my slope is up 2 over 1. So let me just add a few more lines. Okay. Up 2 over 1. Up 2 over 1. Oh, I wanted to make those yellow. So these are my points. So you can kind of see my sloppy line because I'm doing it with my mouse and something like that, right? There's my graph. So it says find the value of the function at the given point. Oh, I don't have that there. Oh, the given point. Sorry, this given point. What will the temperature be at 12 p.m.? That's the question. I was like, wait, where's the given point? Okay, so we need to find the temperature at 12 p.m. So if at 6 a.m. is our 0 hour, right? This is our 0 hour, hour 0. How many hours have passed to get from 6 a.m. to 12 p.m.? 7 to 8 to 9 to 10 to 11 to 12. So 6 hours have passed. So really what we're finding is f of 6. So they're asking us here at 12 p.m., 6 hours have gone by. So I'm really finding f of 6. And so it tells you right here, which is it? Well, it's this one. Because if we're using f of 12, that would mean 12 hours have gone by and it would be 6 p.m. We're looking at noon. So now I can just solve my equation by plugging in 6 for x. 2 times 6 is 12, and 12 minus 3 is 9. So that means if I continued my graph all the way to x is 6, 4, 5, 6, my line should be at 9 the point would be 6,9. So it's 9 degrees Fahrenheit. Okay. So we're not going to do this. It would be a similar idea. The two takeaways, big ones are when you're changing a linear equation to function notation, just rearrange it so y is by itself and then it's f of x equals. Okay. And then you're starting to think, what is my x? And so when it's asking you to evaluate f of 6, you just plug in a 6 for the x. If it said f of 94, you would just plug in a 94 for the x. 2 vocab words that you should write down that you will need is independent variable and dependent variable. So when we are talking about x's and y's, right? Or when we say f of x equals something, equals all of this stuff, what ends up happening is f of x is the answer. It's the dependent variable. Why? Because it depends on what you plug in for x. So when you're talking about functions, x is the independent variable because you get to choose that. Like here, I get to choose the hour I want to evaluate. And once I choose the hour, I can solve it. And the answer, f of x, depends on what I choose. That's what it means. So take a second to add these. And I will see you guys next time. Make sure to do a live class with you next time. Okay.